and welcome everyone to our Innovation2GO for Digital Twins webinar, the Digital Twins and Reverse Engineering. This webinar is planned in the context of the Interreg EMR project, EMR Digital Twin Academy. And our today's guest is Thomas Kropp from D3 Systeme GmbH. And he presents a device which 3D scans plastic components in order to subsequently carry out fully automated quality control. The aim of the development was to make quality control as simple as possible in order to be carried out immediately after the production. But before we go on, I would like to ask you all, is there anyone who prefers English as language for this webinar? Because I think in the end, we have one guest from Belgium. What does the rest of you think? English or German? Do we have if anyone has a preference for English, please raise your hand or write me a text. Otherwise, we can go on in German because we are all Germans. German is fine. Oh, perfect. So I think, lieber Herr Kropp, dann würde ich auf Deutsch Ihnen den Screen überlassen. Den haben Sie eh schon, aber bitteschön. Ich bin gespannt auf den spannenden Vortrag. Vielen Dank.
Ja, dann von meiner Seite auch.
Wait. English. Yeah. There's one. English.
We swap over to English.
We swap over to English. Yes. Okay, thank you very much. Yeah.
Hello to everyone. Also a short introduction of myself. I'm studying industrial design in Wuppertal here in Germany. I'm an industrial designer, and during my career, I learned a lot of different skills, and even I also run a lot of different applications to get familiar with all these creative suite, with CAD, CAM, with measurement, with renderings, and so. Yeah, this is the skills. They are really a good benefit for your daily work. And first of all, I just like to outline my speech today. So we're talking about the digital twin. And specifically, we're talking about reverse engineering aspects for the digital twin. Then I want to introduce some technology about 3D scanning. We're looking a bit more to the raw material, what comes out from a 3D scanner. And then we have a short look at the software which supports this kind of tasks. I want to have a brief look at the workflow. And at the end, I want to see or show some example and projects we're doing on our company and I did in the past. And so first of all, digital twin, I don't want to spend too much time for digital twin. I think everyone here in the audience has some clue about the digital twin. If not, you can go to Wikipedia or you can go to the internet. There are a lot of sites where you can get specs from behind. I want to more point out these tasks like reverse engineering, scan technology in combination with the digital twin. For example, when you buy a computer with an operation system, for example, Windows 10, this is a black box for you. Yeah? You cannot erase the curtain and look behind these kind of operation system. You don't know what it does. It does something you want, for example, it sends you the email, but how it does it, you won't get any answer from Microsoft because this is a proprietary program from there, and they are not willing to give you the source code. Instead of this, you can, for example, use Linux, and Linux is an open source system, and for sure you can get the source code and you know exactly what this operation system does with your data, how it manages the data. And also when you look at, for example, for hardware, for machinery, for spare parts, this is the same issue. Like the manufacturer won't give you more details like a manual, or they give you maybe a small technical drawing as an overview, but they won't give you really hard facts that you maybe can rebuild the machine. But this is not the idea of trading. Yeah, you can buy it and you can work with it, but you are not the owner of these property from the machine. And there comes the point that you need some stuff. For example, when you have hardware and you want to, or you need this hardware for your workflows to build up maybe a kind of digital model from your whole workflow. Sometimes even you need hardware. And in most of the companies in the shop floor, they have these coordinate measurement machines you see on the upper left photo, and you see a teach-in project on the lower side of the screen now, and you can imagine these devices, a tactile device, and you get point by point by point, and so it's really a mess to get a whole volume from a body into your computer. For sure, these machines are super accurate, and they are mostly spread in every company, and so this is the beginning of digitalization. But this is not the answer to our question. If you look at the middle screen, you see a structure light scanner from GOM, and below the picture you see the whole volume of this tubular object. And for sure, now you are able, for example, you can get any cross section, you can analyze it, and you see the difference between your scan and your cut data, for example, and you can compare it. And this is the benefit of these 3D scanners now, that you can really get really fast answer of the geometry. On the right side, you see this portable laser scanner. For example, we have these in our company, and this is really fine because this is just a laptop equipment, and here the scanner, which is handheld, and you can bring it down to the shop floor from your client and do the scan over there, because most of the tasks have to be done on the client side, because the part is too big to send it to your company, or even it's built in a big machine and it can't move out, and so you can do the scan over there. And for example, I have a picture from a colleague from mine. This is the super sport car for here from McLaren, and the order was to get a clue of this mirror. And in the foreground, you see this laptop where in real time the scan happened, and the colleague has this handheld scanner in his hand. You see these laser lines spreading all over the chassis from the sport car, and also you see these little dots which is sticked on the surface. This is the reason, because the scanner needs some orientation, and with the stereoscope camera, he looks at the stripes, the behavior of the stripes on the surface, as well on the measurement points to orientate and to get the location of the results into the computer. And the accuracy is about 2 up to 5 microns. This is really good for reverse engineering tasks, or even for measurement tasks. And every one of you who has a child in a house, they knew in the first period of this pregnancy, the ultrasonic pictures. And for sure, today, these machines are even able to set up a 3-dimensional file into the computer. And there's, for example, even a movement in America where they print out these embryos with a rapid prototyping printer, and you can take your baby home in a very early stage. It is possible. If it does make sense, I don't know, but anyway, it happens. And the next thing is the high-end solutions is industrial CT or X-ray, and there you have, for example, the big benefit that you can really look inside a volume, which is impossible by a laser scanner or a structural light scanner. For example, here you see the skull, you see the brain, you see the eyes, and even there you have information you can give in to a computer in 3 dimensions. And this is really a good tool to run specific or complicated parts. Yeah? And if we look a bit deeper in this kind of technology here, first of all, we have mostly in these kind of scanners, we have a kind of light source. It could be a laser, it could be a stripe light processor in the structured light situation. And we have one or more cameras in a specific angle looking at the target. And in case of the structured light, you spread out some lines, and the stereoscopic cameras look at the lines and send it back to the computer and operate it to a point cloud. This is mostly the way most of the scanners is working. And so if we look a bit more deeper to this raw material, which is now into the computer, on the left side, you see this picture, but this is not a picture from a plastic housing. This is really a point cloud. If you look a bit more closer, you see these little squares, and these squares have also the informations of red, green, and blue. So it's a fully RGB image which you can translate or toggle or turn around with your mouse. And actually, this is a point cloud, and this is the raw material which every scanner does. And the way how the data is going through the computer to the existing part at the end. Yeah? And in the next process, this is a standard data format, which maybe any one of you know, this STL format. You might know it from 3D printer. The STL format is the most common format for all the printers. If you have a closed volume, you can print it. And the idea of this STL format is, when you look at the point cloud before, there's a couple of points, always three, building a small triangle with a normal on this face. And even the neighborhood points are also connected to the next triangle, and so on and so on. And so at the end, you get a nice triangulated surface, maybe with holes, and you are not able to print it. But when it's a closed volume, watertight they call it, then you can also print it. And this is also a data format some of these CAD programs can read in. Some not, then you have to proceed again a bit more to make these data accessible for anyone. The next thing is the transformation. It's like on the right side, you see these CAD data, and on the left side, you see an example I did for the STL data. And when you look at the top surface, for example, the square, or even the cylinder, or even the fillet, you see in CAD, you have very clear boundaries from these surfaces, from the geometry, and it's done in the STL file by triangles. So for example, on the top surface, you have two triangles, which gives a flat surface, but it's two triangles. And for sure, the accuracy of these lasers are so high that when, for example, when on these flat surfaces, some dust, some dirt, some dents, you will increase the numbers of triangles directly, because even these iterations will be shown in the scan. And if we look, for example, on the cylindrical parts, you see that the size of the triangles increases much more to stick definitely on this geometry. And even in the fillet, the triangles getting smaller and smaller and smaller to catch any detail of the geometry. Yeah? That's the aim of the STL data. And I have some really bad news for you, that there is no smart way to get this job done. Yeah? If you look at the left side, this is a quick surface reconstruction. This is just an algorithm. You can press a button and you get this result. Sometimes it's a volume, sometimes it's even a surface with holes, and for sure you can transport this into your CAD program, but it's really a mess. If you want to drive your colleague crazy, then give such crap to them. He won't understand it, he won't be happy with that. On the right side, you see a proper phase reconstruction. And here you see that any phase and the boundaries of this phase are clearly defined. You have flat surfaces, you have cylindrical regular phases, you have these freeform phases. They're matched really good together and gives at the end a good result where you can start your own project with the scan result. Yeah, and for sure we have to look at the software. Even there, if you look at, we have Polyworks, we have Geomagic Design X in our company. I work a lot of years with Tevis CAD/CAM. These are super expensive software. It started up by 12 to 15,000 and it goes up to 60,000 euro for one seat. And you need a really experienced operator in front. You need a lot of training to run this software, and even a lot of project background to get the best result. So my advice in this is that you should go when you just need it once a year or maybe once a month. Just go to a company who give you this service, like scanning, like reverse engineering, because this doesn't matter, or this doesn't make any sense to try to make it by your own. Yeah? So if you look at the workflow of these kind of reverse engineering tasks, you see on the left side, you see these surface recognition, and normally there's an algorithm, for example, who identify the flat surfaces, the fillets, the cylinder, and even the freeform surfaces. And you can see it is represented by the different colors. And here is something which is going wrong. For example, the cylinder on top needs some additional handmade operations by the guy in front of the computer to cut off the cylinder from the side plane to make a proper volume information. You see on the right side this final volume, which is completely separated. Like you have planned surfaces, you have proper cylinders, you have fillets, you have roundings, and that's what you really need at the end in this project. The next thing is the accuracy. The scan itself, they are really high. So you have maybe 1 or even less than a micron when you choose the right scanner for the task. And here there's also some things the operator has to decide. For example, the biggest volume in this is this cylindric base on this geometry, and the operator has to decide, for example, this is maybe 200 millimeter in dimension, in the diameter. And even on this heat bar, you can see that these blue areas have a different from this theoretic cylinder, about 0.2, maybe up to 0.25 mil. And so you should define the target in the project, how near you stick to the surface. For sure, you can make the whole volume green, yeah, but this is not really what you want. You must know exactly where your dimension should run through, and give the operator even a hint what you want. Yeah? And the next task is also to bring the results over to common CAD software like CATIA, like Siemens NX, like SolidWorks, whatever. And here the same example is transported into SolidWorks, and you see on the left side, you see the parametry tree, and at the end the model is so that you can choose any parameter, like the diameter, like the thickness, like the diameter of the holes, the radius, the fillets, and can change this afterward, and you don't need the operator anymore. This is really the best benefit you can ever get from 3D scanning. And therefore, for example, We using personally, for example, this geometric design X, and there is a benefit if you have, for example, SolidWorks or Siemens NX or Pro Engineer, this Creo on your computer. There's a kind of live transform to export the data with parametry to the targeting CAD program. And yeah, this is the best way at the moment to transport scan data into the computer. And now we come to this point to show some examples and projects from my past, from my company. And so we did a lot of metrology, we do a lot of reverse engineering for a different purpose. And first of all, there's one which is stick directly to Industry 4.0 or even digital twin. Is this buzzword predictive maintenance. Yeah? If we have a spare part, for example, this extruder screw, and we have a complete new extruder screw, we scan it, then we have a base where we can scan it maybe after half a year of usage or even 1 year of usage, and you can see the behavior of the material flow, the abrasive solutions to the material, and then you have can make a future decision, for example, when you expect that the extruder screw have to be exchanged before something really worse happened to your company, and you have no time leaks where the machine does not produce, because in a forehead, in a very clever moment, you can exchange the extruder screw, and so nothing happened to your company. The next thing is, for example, we get an order by a client. This is a principal drawing of a plastic extruder. And here's also what I said before, the manufacturer of these spare parts of this extruder, they give you just an overview. These red little items are made by the client. They hope that they can reconstruct it because they need it for material flow analysis. So they need the actual geometry of the nozzle. And if you see the next picture, how complex such object is, there's no chance really to do it by these overview technical drawings. You won't get any deeper information out from this sketch. And here also we did a laser scan and get the data into SolidWorks, which is the best benefit to start the flow simulation for the client. Yeah? Next task is, for example, quality control. Here even is also possible to scan and to compare cut data with the existing data, or even you can have a golden manufacturer part and you can compare a scan to a scan where you know exactly that this geometry fit to your client needs, and you can see the data which is needed. You can see a little yellow flag on this bar if the measurements are reached, or even a red box when it's not reached, or even green when everything is fine. And even quality control is something a 3D scanner is absolutely need. And the next thing is documentation, for example. This is a client from us, they're making water rights. And in this case, the basic water right, which was sold to his client, is 25 years old. It's handmade, and even the mold is handmade. So they have no data, not at all, not a technical drawing, nothing. But the end client, he needs a proper documentation. And in order to do that, we do a scan of the water right and reverse it, bring it up to SolidWorks again to give a proper technical drawing to the client that to fulfill his wishes to this task. Yeah? And at the end, I want to show some sculpture from the Lehmbruck Museum here in Duisburg in Germany. And the museum itself, they point out the accessibility for disabled people. And the original sculpture is very sensitive, cannot be touched. And in case of guided tours, for example, when there are some blind people, we make a scan and we print out with rapid prototyping printers a smaller version of the sculpture. And when the talks and the guide is talking about the sculpture, they can hand over this small little sculpture from plastic material, and they can get a clue by getting it in the hand and see how the sculpture look like. And yeah, this is also a matter of a twin, which is done by the 3D scanners. I want to thank you for your attention, and now we can go into question and answer, if you like.
Yes, thank you very much for your talk. And now, yes, the question and answers session is open. So if you have any questions, just raise your hand. It's the React in the reactions menu, or you can type them into the chat. The first question from my side is it possible to scan hollow objects? I think it's an optical device you use. It's not because you mentioned this ultrasonic. These pictures of the babies. It's
yeah, this is ultrasonic or X-ray or
okay.
Possible, but this is really super advanced and super expensive machines, and in some cases it will be used, but it's yeah, extremely expensive to
okay.
use X-ray machines for scanning.
So for D3 Systeme, it's possible to scan anything with a surface, not hollow, but
yeah.
Yes. Okay, I know. Okay. There's a first question, raised hand from Olaf Gunnevik. So I think the word is yours. You can activate your microphone.
Yes, hello. My name is Olaf Gunnevik. I'm working for the company Diondo, and we are manufacturers of industrial CT scanners. And we are nearby Velbert. We are in Hatting. It's not so far away from Velbert. And I'm not trying to sell you an industrial CT scanner, but we also have a service department. We have 4 CT scanners in our service department, from very high accuracy to very big samples. And this is one thing. Maybe you are interested in CT services for scanning.
Yeah, I'm very interested. If you're willing to give you your contact data.
Yes, of course. I will send you an email.
Yeah, send me an email, please. This is very interesting for me. Yeah.
Okay.
We can enter your contact data, Mr. Kropp, into our afterwards email when we publish the link of the video.
I think also it's now shown on the screen, yeah, or not?
Yeah.
And
I have a second question. You said you're working for museums. We are also working for museums for digital twin production. And maybe we can also discuss about these topics. Because as you said, okay, blind people, this is one thing. On the other hand, people would also like to understand what's inside, of whatever, a mummy or something, I don't know. And so we are doing also lots of work in this direction. We have a cooperation partner in Switzerland. It's a company, they are only doing digital twins in very, very, very high accuracy for movies, for games and so on.
Yeah.
And for museums, of course.
Yeah, sure. Yeah.
But we can discuss afterwards, no problem.
Gerne.
Okay, then I have 2 questions in the chat, and afterwards I would hand over the microphone to Bernd Enkelkamp. But first, we have a question. Can the scanned objects also be used for virtual reality or augmented reality environment? What file format would be required for this? For example, you showed this sculpture. You could also have something like an app where you can have a 3D model of the sculpture. Is this also possible?
Sure. I did not talk about, for example, LiDAR radar with drones. I do not talk about the possibilities of photos of laser scanners. where you can catch complete buildings or surroundings. We did that as well, but yeah, this is, can be done, and it's a common work in films, in virtual reality tasks, for sure. Yeah, you can do that.
So you can also scan with LiDAR? You do this?
I did this in the past. I was operating manager in a company who does drones. And so we have also drones, for example, with LiDAR radar, and we can fly above the scenery and taking geometry via radar or even via photogrammetry. So this is quite common. And for example, I just read an article about Leica here in Germany, a hexagon company, and they have a partnership with DJI, which is the biggest drone company in China, and they have a very nice drone with LiDAR radar on top, with the Leica software to establish a complete landscape or a house, or even a flight inside maybe a tube to get the informations. And for sure, even color and the surface structure is also catched in these by the same technology as shown at the pixels, where the RGB information is on the scan point. And I did also some experience with the Faro lens field scanners, for example, and the accuracy there is, for example, in a radius of 40 meters, you have an accuracy about 0.2 mil. And really, I saw some details from fences in 20-25 meters distance, and I was really surprised how accurate these kind of scanners are at the moment.
Great. The other question was about your example of the extruder screw. Can the screw in the example be scanned by a mobile handheld device, or is it a static device needed?
No, it's a handheld device.
Yes, and it's the resolution is still good enough for example, predictive maintenance purpose.
Yeah.
Wow. Okay. And the next question, Bernd Engelkamp, thank you for waiting.
Okay, thanks. Thank you, Mr. Kropp. Maybe you already mentioned it, but I'm not sure about the slide with the sculpture, for example. If you scan it, you may only get the geometrical informations. What about the color, for example? How do you involve this for the sculpture? Because it's probably an important factor for the design or for the art.
There are several different scanners in the market, for example. If you really point out to the fact that you need the surface information like color, or even a very proper information from the color, there are some specific scanning systems where you have an additional camera, for example, and the UV mapping, which is needed for these tasks, is really nice. And even when you have an additional camera to the scan system, you have even a much better resolution to match these to the point cloud. In our task, our scanner doesn't see any surface color, because we definitely focus on technical parts where the color is not really necessary. But I did also some project with scanners which can check the surface color information. For example, if you see the photo from the museum, this is a special scanner. They don't need any targets on the object, because the museum's guys, they won't get a heart attack when I glue some stickers on the Lehmbruch sculpture. And the benefit of these color information is there, that the orientation from the scanner comes even from the pattern or even from the color information. The sculpture has little dots inside, and this helps also the scanner to orientate itself. And for sure, this one takes even the color information, but there's also an additional way that you can even add on a camera on top of the scanner to get a better image of the surface and match that later on with this UV technology. I don't know if you're a bit familiar with this. It comes from this rendering or from this film equipment that you have a kind of pattern which is distributed on the surface to give a nice color shape on this geometry which is in the computer.
Yeah. Okay, thank you.
Okay, do you have further questions? Yes. I think we don't have any further questions right now. Last chance. No. So again, I think we will provide the screen recording and the contact to Thomas Kropp afterwards. So if you have any further questions, you can ask us or you can ask him directly. So I think this was a very successful meeting. Yeah, so thank you very much, Thomas Kropp, for your presentation, and to all the participants for your questions and your interest into this topic. And next week we will have the next Innovation2GO webinar. You can find it on our website. And thank you very much and have a nice evening.
Yeah, thank you to all of you and bye-bye.
Bye-bye. Thank you.
Bye. Bye.
Thank you. Bye-bye.